saw it and he took a photo of it.
Did it rattle?
It tried to, but it doesn't have a rattle.
Okay,
Right.
those little
Gopher
suckers,
snakes
those
do not
babies.
have a rattle.
What, Tom?
Gopher snakes do not have a rattle. That's one of the big giveaways. Yeah.
Gopher
Snakes
snake.
don't have a rattlesnakes
Gopher
do.
snakes do not have a rattle.
Right.
Oh, I see.
I'm getting a warning that the content of this meeting is being sent to a third party.
Yes,
Oh,
YouTube.
Oh, okay. I
You
never
are
got
now
that before.
streaming live on YouTube.
that's what
I
mine
never
says
got
too,
that
Jerry.
third party warning before.
Okay.
Yeah.
It's not going to Vladimir Putin?
Yeah.
Okay.
Are you going to be able to use the talking points? Anybody?
Yeah, I can.
Oh,
good,
yeah.
good.
So
I've
I'm
got
going to go. I'm going to get the YouTube up. It's not going to tell. It's not going to tell us anything, but.
Tom Whittemore,
Yeah. Morning.
married to a lovely lady by the name of Maureen.
Yes.
Did,
Yep.
did you, by any chance, Tom, get a stupid little silly pun email from me over the past week?
I think so.
Would you remember? Because I'd love to launch a thing called the weekly Whittemore Witticism. If you can give me, if you can give me the punchline. Why is
what was that? Did you
why?
get
I'll tell you what it is. Last week you did the one about the hokey pokey.
Oh, yeah.
And you're full of these, so I'm going to add the Whittemore witticism every week if you can remember. Why is it that science has discovered the iris of the eye is the last to pass away when we die, when we pass away? Why is that? Do you know?
Yeah, because they die late.
Oh,
I didn't invent that, Tim.
That's okay.
No, there is a pun website, and I scan that sometimes, but I pretty much reject all those puns, and that is an example. So
yeah,
Tom
we can include them if you want. Can you see my screen share?
Yes.
Okay.
Oh, I'm sorry. No, we can see you.
I can see your face, Gary.
Okay.
Yeah, everything's fine with you. We're back on target. I guess we fixed the
You
problem.
might be in trouble.
We're late.
Never mind.
There you go.
Here we go. To the silly cartoons that were forwarded to us. Talking head, the lady says, astronomers initially said there was a 1 in 6,000 chance that newly discovered asteroid might do something cool in 2063. But further observations determined it'll be just a boring dot like all the others. We won't be around anyway for that. So nothing happening in the future. They're no fun. More talking heads. This is the new alarm, sky alarm. Wee-wee! There's a cool space thing happening. Everybody, wee-wee! Go outside and look up. We all got to have this device. So Alexa and Siri, eat your heart out. We got to have one of those. You know what this reminds me of?
What?
That service back in the 80s and 90s that would call from LA if there was a freeway chase. Channel 9, I think. Remember that? People would love to go on Channel 9 down in LA. Probably wouldn't hear. Here's the science officer in a spacesuit on the moon walking forward. Science officer's final entry. He punches in. Planetary readings indicate absolutely no signs of intelligent. I have a feeling you might be able to bounce down the side of that and live on the moon. Maybe in Mars as well.
You don't know what's down there.
Yeah.
Well, that's good, funny stuff. Here is Ugaraka and his wife Wilma in the future or in the past, caveman, being revisited by the green alien who's overparked outside saying, hey, you guys were doing the same thing when I visited 10,000 years ago. Caveman says, yeah, we then created AI, which took all our jobs except for this one. That puts it in the future as far as I'm concerned. And here's the moon talking to the Earth saying, Earth, want to see something cool? Sure, Moon, says the Earth. Says, it's my new dance move. Cool, says the Earth as he does his Gene Kelly, Fred Astaire. Wonderful. And there's carnage and tidal waves in the oceans of the world as it shimmies in space.
Yep.
Yeah.
I love some of these. All right, this always starts us out.
I think he was doing the moonwalk, Michael Jackson.
Yeah, he was doing the moonwalk.
Because of the hat. See the hat? Yeah.
Yeah. You're right. Here's more talking heads. This meteor shower weekend, remember, if you find a meteor on the ground, don't try to return it to the sky yourself. Instead, contact an observatory where astronomical rehabbers will care for it and hopefully release it back into the wild with the next space launch. It's kind of an astronomical ASPCA for wayward rocks. And two triangles meet in a bar. One of them says to the other, "What's your sign?" He says, 8/10 over the square root of 2. What's your sign? Other one says, "I'll give you my
Trigonometry
cosine."
joke.
Yeah. Here's two scientists. This is Gary Larson's far
Yeah.
side. No doubt about it, Ellington. We've mathematically expressed the purpose of the universe. God, how I love the thrill of scientific discovery. It all
You see
equals
it, all their reasoning equals zero.
Yeah.
That's the sum total.
You suppose he says God in the middle of his soliloquy for a reason there? Is that a little pun or
Well, it's just
irony?
an exclamation of surprise.
I know, I say goodness.
Hmm.
All right, that's good stuff. Good old Larson lives on.
Yeah.
You flooded us with those over the weekend. You got it done. And
Yeah.
we're on the air somehow. I don't know how we do it, but there's always something in the Zoom world, including, I guess, coming up. What do we got? Equinox? It's
Mhm.
Sunday?
Hmm.
What happens during an equinox, Mr. Prez and the rest of you?
Can you see this at share?
Yep.
Yeah. Oh,
Okay.
yeah.
So this shows the Earth with the North Pole straight up. It shows the ecliptic, which is where the planets go around,
Mhm.
the plane of planets. The Earth is tilted 23 degrees from the ecliptic. So the celestial equator is the projection of the Earth equator on the sky, and it crosses the ecliptic at two places. The September or autumnal equinox and the March or spring, what is it?
Vernal.
Vernal and autumnal, yeah,
At least for the Northern Hemisphere.
right. Yeah. So, and these define, by some standards, these define our seasons. So going from, we're just passing the September equinox this Sunday, and we're headed down toward the December solstice around this way.
Mhm.
So we're now entering fall. At the depth of this down here is when winter starts, and then we go back up to the spring equinox.
So the sun will rise directly east and set directly west, more or less. So
Yeah.
Right.
Is it equinox or solstice that they aim those ancient rocks and
Both.
pyramids
think
so that the
both.
sun goes right down and hits it one day a year? What is that? Is that summertime or
Either for
winter
both.
time?
Yeah, those rock circles are meant to be calendars, so they line up with different features at different parts of the year, so they can tell what part of the year they're doing. We've moved away from those kind of things because it's so hard to adjust them for daylight savings time.
yeah.
Well, there's something that happens on one of the major streets in New York.
Oh, yeah.
There's an accidental alignment of the grid of streets in New York with the setting sun in the summer
Right.
solstice, I think, yeah.
Did you guys see that article about Van Gogh and how he, I think it was a recent Sky and Telescope, very recent, in how Van Gogh painted the setting sun down this avenue of trees. Okay, it was in Holland. And it's really neat because what happened was the sleuths that chased all this stuff down realized, there was one of those avenues for, artists too, for the setting sun. It's a really neat little article. I think it's a very recent Sky and Telescope.
Is that one by those University of Texas folks that go around and do all these art?
Yeah, I think that's it, Chuck. Did you get yours yet?
Yeah,
I got it. I haven't read it yet.
Yeah.
Tom, it's on page 30 of this month's or it's of the November issue.
It's the November issue because
Yep.
it just came. Yeah.
Yeah, I just saw. I have it right here, so I was looking at it.
Yeah, it's really neat. It's really neat, and that they show Van Gogh's definite style, of painting, and then looking at these trees, these painted trees, at the sun, and they actually ID'd there was a house, at the very end of this painting that they actually ID'd, and I guess it's still around. I think it's still around. Yeah.
His style of painting was just blobs of paint somehow made sense and looked like something, you know?
Isn't that all painting?
Yeah.
I have an aside on that. I saw Van Gogh. I was with a friend who had a book of all Van Gogh stuff, and there was a picture of him with a guy sitting in a corner, and I was really tired, and my eyes were real blurry. And I looked back at that painting, and I swear to you guys, it looked like a photograph. It was just whatever it did to my eyes, it tricked it, and that's why I think his painting was genius.
Yeah, and also in the article are letters that identified this painting to his brother Theo. You know, back and forth to Theo.
Yeah, I see the article. I'm gonna read it, Tom.
It's real good.
Yep.
Okay, up to the night sky. Here we go for the planetary roundup.
Yeah,
This
that's
is the morning sky.
It's morning
This is
sky.
in the
Morning.
east.
Good morning, Sky.
Morning. You can see this.
Sky King. Okay, what are we looking at? In yellow there.
You can see the start of dawn here. The sun is about to come up. Mercury is very low in the east.
Yep.
The sky is much brighter than this at this time, which is 6:30 tomorrow morning.
Yeah.
So, but that's where Mercury is.
Yeah.
And
I was going to say about a week ago, Jerry, or so, Mercury was pretty close to Regulus. It's really zipped down.
Yeah,
really
right there.
down toward the sun. Yeah, it was very.
Yeah,
I caught it one morning, but it's been pretty bad cloudy weather.
yeah, we've had bad weather here as usual. The Mercury is moving down.
Uh-oh.
Mercury is always low. It can never go high, right?
19 degrees, I think.
Yeah, that sounds right.
Whoops.
And Venus isn't much.
Okay, Jerry's back.
Scared us for a minute ago there.
Yeah.
Yeah, let's see. I was looking for another planet. It's not in there. Okay, good. Here we go. Okay, this is at 7 p.m. This is the evening sky. The Virgo cluster is just about to set. At this time, 7 o'clock, it's still too bright, but you can't see the Virgo cluster like it implies you can here. But this is because it shows Venus, which is low in the sky. It's working its way into the evening sky now.
And as Chuck just mentioned, you see how the sun is setting almost due west now.
Yeah.
Oh,
That's
interesting.
right. Good point.
That's what that glow is. Okay.
Yeah, I saw Venus as late as about 8:30, but it's on a real low trajectory because
your house is up on a hill. You're going to be sees best.
But technically, for us, since we're above the Tropic of Cancer, it's sort of southwest. It would only be directly west if we were on the equator, right?
No.
No?
No.
No, it's close to the sun, and the sun will be directly west.
Right. On the equinox.
Right.
But it goes a little further north in wintertime at the next solstice, with the winter solstice, right?
What's
Well,
that? The sun?
No, the sun is headed south now.
Yeah.
I mean.
Right. I'm sorry. It's the other way around. I'm sorry. It's summer solstice, it'd be higher.
Okay.
Yeah, I understand the concept.
Now here is about 1:30 in the morning. You've got in the east, you've got Mars and Jupiter rising. So for the rest of the night till dawn, they're good objects to look at. Jupiter, you can spot even earlier than 1:30. It's going to
must be getting near opposition. Yeah.
It's going to become and Saturn was at opposition last week. So these are pictures taken by an amateur of Mars and Jupiter, and his name is
Sean Walker. It's on the image.
Yeah, Sean Walker, but he took it with a C-14 telescope on I have the date here somewhere.
September 4.
Oh, yeah, there it is, September 4th.
Yeah, there it is, right on the caption. Pretty clever. I hit it there.
It's hidden in front of us, Jerry.
Yeah, and it shows these are the universal times he took the picture, very close to each other. So they're both up. And this one is 6.6 arc seconds across. It's give us Mars. Here is the disk of Jupiter at 38.5 arc seconds across. Jupiter, when it's closest, it does reach 50 arc seconds across. And Mars will get as high, at some oppositions, will get as high as 25 arc seconds apart. So it will be 4 times this size, be up to here. And then you can see a lot of detail. With his C14, he's picking out a lot of detail here.
We're not getting the detail because of the computer, Jerry.
Oh, I'm sorry. Well, it can show Citrus Major and the polar cap.
Okay.
But we'll move on. Okay. Now this is
Tomorrow night.
Mars is going to occult Saturn for some locations.
Tomorrow morning.
Yes,
Yes,
September
tomorrow morning.
17.
In the west, yeah.
Yeah, this is
Really?
in the west. And this is the way my planetarium software is set up. It doesn't show the occultation. It shows a very close approach between Saturn and the Moon. But from here, this is the path of the occultation of Saturn. Here we are right there. So it starts here and ends down here. We are definitely in the path where we can observe it. And
Wow.
And it's between 4 and 5 a.m. I think at the meeting I said 5 and 6. So I've subtracted for standard time.
yeah. Oh yes, the chart I showed, the chart is unfortunately in the text. I didn't make a slide of it.
Yeah.
But you can tell it starts here. Let's see, for Los Angeles, which counts for us, Saturn disappears at 4:10 a.m.
Yep.
Pacific Daylight Time. So this is right here. This is 4:10. So this is at disappearance, although I didn't adjust the planetarium software to capture it well. My apologies. The moon is 21 degrees high in the southwest. Saturn reappears at Los Angeles at 5:05 a.m. So it's hidden for 55 minutes.
So that's the
In
bright
that
blob
time.
we're seeing is the moon?
This big glob up here is scattered light from the moon being in the sky.
Yeah.
This is the moon right there, and there's Saturn right there.
Okay.
Oh, okay. So it's the occultation of the moon. Okay.
No.
No.
Occultation of Saturn. Saturn will disappear for about an hour.
Yeah.
Occultation of Saturn.
Can you
Okay.
Can you go back to that track on the planet that has us in it for a second? It looks like a tube. I just have one question. Okay. People that live north of that little tube design see one of the planets go above the other or below it.
That's
and the
right.
Same for people below. They won't see the occultation with that we
Right.
will.
Right.
There's that much of a parallax distance angle.
Yes,
You know what I'm saying?
because the moon's close.
Yeah. The moon is a half a degree apart. So this is a parallax of half a degree on the Earth's surface.
Oh, wow.
If you're up here, it'll be a half a degree miss. If you're down here, same distance, it'll be a half a degree miss.
Yeah. And a trick, Ron, that I always remembered is the moon moves through its diameter every hour. So the moon must move by about 1/2 of 1 degree in 1 hour. Okay.
But I swear I thought I heard you say Mars was occulting Saturn, not the moon.
No, it's
the
moon.
moon.
Yeah.
If
Oh,
I
the
said
moon is-
Mars, it was an error.
Plus,
Okay.
Mars would only be a partial occultation.
Yeah.
Okay, I was wondering, that's awful rare. That's a
Yeah.
1 in a million odds that those two little dots that are planets. So this is a moon thing. Okay.
Uh-huh.
But this isn't that partial eclipse that I talked about
That's
in the
coming
headline.
up.
Yeah, that's
Well,
coming
this
up.
is it.
No, that's a lunar eclipse. This is a Saturn occultation.
Yeah.
Right.
Okay.
That
And the
involves the
moon's
moon.
responsible for both,
Yeah.
if you like, or visible for both.
Now,
Okay.
this is a picture of Saturn taken the other evening, June 1st, by Christopher Go. And
Mm,
it's upside down from the one we showed a while ago. So you can see the shadow of the rings is up above,
wow.
but it's a very nice picture.
Yeah.
Now, here we have the other one to finish off our planetary. Where are they? This is Uranus up here, or excuse me, Doug. And this is Jupiter and Mars here at 1 a.m.
Right.
On the
Mhm.
other, also, and in here is the Hyades
Mhm.
with Aldebaran in Taurus. So these are winter constellations coming up. The Pleiades here, things to come. These will be in the evening in about 3 months.
Ooh, binocular time.
Yeah.
Oh yeah, yeah.
Gonna have to buy me a set.
Now this is a image of the moon with the penumbral
Eclipse.
eclipse,
Mhm.
like we're going to
That's the
see
partial
this
umbral. Partial umbral.
partial umbral.
Number is also on there.
Yeah.
And
It's
it's
just
the
a
Earth.
little nibble, Ron, just a little nibble this time.
Okay,
you're
is that
right.
our Earth's shadow on the upper part?
Yes.
Yes.
Yeah. Mm-hmm.
This was occurred on November 8th, 2022, and it's a similar eclipse to what you're going to see this week. Just a faint shading of one part of the moon.
Okay.
Now,
And that's,
A binocular thing to do, Ron.
and
yes.
it's the same, and it's the same for everybody on the Earth. There's no track on something like that.
That's correct.
Mm-hmm.
And here we are in Pacific Daylight Time. We will not see the shading first appear, but at the greatest eclipse, which won't be very much, will be just before 8 p.m.
Mm-hmm.
The moon leaves the umbra at 8:16 and the shading disappears. And the moon leaves the penumbra, the faint outer shading, about 2 hours later from the greatest eclipse. So it's going to be subtle. You'll want to take a photograph if you want.
Would it be something that like outreach wise, would people be able to see this? Or is it dimming?
Yes, if it's pointed out to people, they're not going to look up and say, "Oh, what's happening to the moon?" You know,
Yeah,
turns
Yeah, it's gonna
red.
be pretty subtle, Tim.
and it's also at about 14 degrees. I think it's not very. It's really low.
Yeah.
Yeah, the moon will come up under eclipse, Tim.
Yeah. I think I think when we're going to see it, I think at that 7:44. I think it's only at 14 degrees if I remember.
Right. Yeah. And because we're so close to equinox, Tim, so the moon will be pretty close to the east point.
Oh, okay.
Yeah, pretty
then
close.
We have our mountains and stuff to deal with.
Yeah.
Not us, Chuck.
Yeah.
Probably a
Go ahead, rub it in.
thing.
Well, if we could take you back to the 50s with Giselle McKenzie and your hit parade, it was shine on, full harvest moon. All right.
Okay, this was a neat photograph.
Yeah.
Taken by an amateur. The Earth is not there. It was added for scale to show how big these things are.
Wow.
It's just added on. But it shows a detached portion of a prominence.
Mm-hmm.
There's very faint, you probably can't see it on your screen, but there's very faint trail there and a very faint around here.
Wow.
What happens in all these things is the magnetic field, which has no beginning or end, it's just a loop. It just erupts out of the sun's surface, just like your cat pulls a thread out of your carpet, and it's a loop. Wonder whether to cut it off or try to work it back in. So it goes up there, it aligns ions in the solar atmosphere up here, which are very hot. And by aligning them, it defines a lower temperature, it cools them off and they become visible. And the material falls back into the sun. All the material is falling back. As the loop goes up, the material falls back. Some videos of it real close up show that effect very dramatically.
I've never, that's real. I didn't even see that loop, Jerry.
Yeah.
This one.
Yeah. And I didn't understand until you described that, how it cools and then it becomes visible. That's something I didn't realize.
Mm-hmm. Well, it's a higher density too. And the loop, when it comes up, it does bring material up with it. And the material falls back down and the cooled material falls back down.
If you colored it green, it'd be broccoli.
Yeah, right. Okay, now I just went to Ireland last month.
Yeah.
And got COVID when I came back. And the COVID still has effects. It gives me what's called visual migraines.
Wow.
And they hit at odd times when I'm tired. And so I can't see for about 20 minutes as this pattern slowly goes out and ruins my definition.
Wow.
But aside from that little irritation, it was a wonderful trip.
Yeah.
This is a picture drawn by hand in the 1840s or shortly thereafter by Lord Rosse, who built the world's largest reflector at that time. It was the world's largest telescope from 1845 to 1917 when it was superseded by the 100-inch at Mount Wilson. His telescope was 72 inches in diameter. It was 6 feet, a 6-foot mirror. And they didn't make mirrors out of glass at that time. They used a mirror, an alloy of tin and copper.
Silver. Tin and silver, I think.
Copper and tin.
Copper and tin, you're right.
Copper and tin, okay. And it called, oh God, what is it called?
Speculum.
Speculum, that's right. And what that does, it's a disc, and if you curve it to the right shape, which is an art in itself, and then polish it, it's very highly reflective and makes a great telescope, but it's also a reactive chemical. And so when you're in Ireland, in the town of Birr, at Birr Castle, the thing tarnishes in about 6 months, and you have to take the mirror out and you have to take it back to the shop and you have to regrind it and refigure it. And he had a shop that he did that in, and you'll see a little later, I'll show it to you, a rail cart that he pushed along a little railroad to exchange mirrors with the shop. So he had 1 or 2 mirrors in the shop that were ready to replace, and then he would take the dirty one out of the telescope and put the other one back in. He was the first guy to give us a look through these kind of drawings of spiral nebula. We know these are galaxies now. He didn't know that. He thought and nobody knew that. They thought they were just clouds of nebula that had a spiral shape. This is actually what we call M51. It's 2 galaxies together in Messier's calendar or catalog. Very dramatic.
Jerry, can I ask how did they end up seeing an image from that tin and copper curved mirror? What would it go to? What would it magnify into? A lens somewhere up front?
Folks, he's not a shill. I didn't plan him there with that question. But I'm about to get to that.
I can't imagine them standing in front of it and they'd block the incoming light just to see.
No, he didn't do that.
That's what Herschel did.
Yeah.
You tilt the mirror so that the focal point comes to the very edge of the tube. And then you would look, and your head is such a small thing compared to the size of some of these scopes.
And Herschel had the same problem with speculum as this one does.
Yeah. And Herschel tried to get politicians to look in the telescope because they had the smallest heads.
Yeah. I'd like to welcome Bruce Murdoch to the screen. Bruce.
Oh, hi, Bruce.
Time got away from me. Sorry about that.
It's okay. We had technical difficulties. You didn't miss much.
Yeah.
So anyway, these are 2 walls. There's 1 wall and there's another wall back there. And the telescope is laying right down there, and it's pulled up by cables so that it can point it can go and point in altitude this way, and it can tip very slightly side to side. And but it can't run into these walls. When it does, that's the limit of its travel. So it's an altitude azimuth mount. And this is a walkway. Depending on how high the tube is up, you go stand in that part to see the eyepiece look in from this side. And this walkway or catwalk moves back and forth on these rails up here so that you can move it out to wherever the tube is pointing. So it's a very crude, very basic design, but it works. And this.
How many times did he fall off?
What's that?
How many times did he fall off?
You know, apparently he was very conscious of that because he's got railings everywhere.
Okay.
I swear I've seen stuff like that in the Dungeon and Dragons video game. Looks exactly like it.
Yeah, okay. So this is the plaque. It's 72-inch diameter reflecting telescope. Constructed, it was finished in 1845, and it was the biggest telescope in the world from 1845 to 1917.
Wow.
Then it was restored by, God, I don't know what that is.
That's the prime minister, basically. That's Gaelic for their prime
Oh,
minister.
I can't. Okay, thank you. John Burton, and this was done in 1995, and the thing has deteriorated again since then. So it needs more work. But this is the front end of the telescope. These are shutters. One opens up, one opens down, or else it looks like they unclip and swing down this way. And
I had no
that
idea
way.
it's made of wood.
Yeah, they're made of wood. The tube is made of wood,
I had no idea.
like a barrel, and there's
Like a
straps around it and stuff.
Yeah.
These are counterweights, so it doesn't take much effort to lift the tube. These are the cables. They're symmetric on each side that lift the tube. In the back this is the back end down here. These are rails where the little push cart, which is up here, brings it down to change mirrors.
Huh.
So
Well thought out, really.
it is very, just like amateurs. You know, when you're sitting around with a big pile of wood and a couple of discs of speculum, you think, what can I put together to make life happen?
Exactly. Get some
Jerry,
plumber parts.
Yeah.
Jerry, you said it was in the town of Burr. What is Parsonstown?
Parsonstown is what that area used to be called. It's
Yeah.
Parsons with an S.
Name for a parson? A religious guy, you suppose?
No, that's
Probably.
names, it turns out, in Ireland, we were told, are very regional, because the families that were there that didn't leave, they didn't have trains and cars and stuff. They went everywhere by walking or horse cart. So names were fairly regional. And Pat's family, when they were in Ireland, was named Lynch. And that's a southern name down around Cork. There's a lot of Lynch names. Up
And
in
Lord Ross was Earl's. His last name was Parsons, so that's why you got Parsonstown.
Yeah, and he was actually English, and he did not fit with the culture there. And when they had their revolutions and fights with Spain and stuff, actually Spain was earlier, but when they had their revolution, he moved back to England and left this alone. So it was unoccupied for quite a while. But the Ross family moved back into it in the 20th century, the mid 20th century.
Hey, Jerry, what is that thin wire on the little cabling there? What?
Right there.
Counterweight. Counterweight.
Well, no, that's for switching the eyepieces.
Yeah, we'll see that a little closer. Up next slide.
Oh, okay.
So, but this is where the eyepiece goes. There are two eyepieces that were made for it. This is I think it's about an F10 telescope, somewhere around there. And so it's not a high performance short focal length telescope. So they have very crude early eyepieces like Higgins and a Ramsden eyepiece that are very simple eyepieces with simple non-achromatic lenses, but they work very well on these long focal length tubes.
The
I
way
thought
Herschel made his
the weight
eyepiece-
was a counterweight that allowed you to move the diagonal up and down to focus. The diagonal on eyepiece.
Yeah. Yeah. See, here's that cable again.
Right.
And so you can move this the whole thing in the slot, this whole assembly. There's both eyepiece. These are not the eyepieces. The eyepieces are in the museum, but this is a blank that fits in there. But you focus by moving this whole thing, sliding it this way.
Oh, how interesting.
Well, you switch eyepieces, yeah.
Yeah.
Wow.
Did you take these pictures, Mr. President?
Yes.
Well, so
And
you
here's
got
the-
right
here's-
in that, you got right into that interesting structure that looks like a little castle.
No,
there.
you're not allowed in. I just zoomed in a little bit with my camera. You're not too
Oh,
far
I see.
away.
Okay.
These are fabulous pictures, Jerry.
Oh, thank you. But you can see the wood structure of the tube there.
And
Yeah,
one of the
they're-
lenses is huge. I mean, it's even bigger than a Nagler.
Yeah. Oh, yeah. He's put Naglers to shame.
And
they must have had like Cooperage is what the guys that make barrels. So they must have had, they must have had somebody like that come in and make that.
Oh, I'm
tube.
sure that's
yeah.
I'm sure that's true, Tim. I'll
Yeah.
bet you.
Tim, this place is called the Domain. The Bird Domain, or it's DEMESNE,
Mhm.
and it's like 2,000 acres
Wow.
with a castle and all this. So he had a whole staff, of gardeners and coopers and you name it. Plus, I don't know if you ever heard of Parsons turbines and Parsons boilers that were powering ships for decades.
Right.
This whole family was heavily involved in science and engineering and stuff.
Yeah.
Yeah,
And,
that's right. He did
experimenting
that.
with photography and electricity. They even had they have a river or a stream that runs through this place, and they put a turbine in there to generate electricity and electrified the whole castle area before they had electricity in the general populace in Ireland.
Yeah.
That's very interesting.
This guy was a very creative engineer, and they have unfortunately, I didn't include that picture, but as Chuck said, he made turbines for steam turbine power on ships, and they have one of his turbines sitting at the entranceway to the whole castle.
Huh.
Now
So-
this is the back end of the telescope. There's the telescope way down there. This is a winch that lifts it up from the back, and these are the under there is the tape. On the other side is the cart that would be used to lower the mirror down and replace the mirror on the back of the tube.
Now, what did they use to? What were the cables powered with? I mean, it couldn't have been just cranks.
No, electricity.
Oh, electricity. Okay, all right.
Yeah, but at first it was cranks.
Yeah,
Yeah, it's the Armstrong engine.
the Armstrong engine.
They had the counterweights that made it a lot easier.
Right. And then there were also, they had horsepower and stuff. Ancient people are way underestimated. You have loony things about from modern people about how the pyramids were made. But people were very resourceful, and they had the same tools we have. They understood ramps, and they understood leverage, and they understood cranes, and they just didn't have electric or diesel motors. They had human power and animal power. It just was slower, but they got it done.
Well, did I miss the part where it turns on a round table? Like it goes around as well?
There's no round table.
Oh, that doesn't turn. It only gets one slice of the sky then.
That's right.
It can move slightly back and forth within those walls, but that's it. And basically what they did is they would either try to follow a target for a short time, as the sky rotated. This is oriented north-south.
Right.
Or they would just watch as stuff scan through, and they would try to keep an accurate clock. And that's, right ascension basically. And that's what they would use to determine the positions of things. And they would just, especially Herschel, would just watch as stuff went by, and he would call out, "Oh, I'm seeing this. Oh, I'm seeing that," and his sister would write it down, and they would do similar things here.
So
During
this is
that period, you said they had electricity. They didn't also have photography, did they?
no, they had drawing.
Yeah, they sort of had those both around the same time.
Wow.
Lord Ross's wife was big into photography, and not so much astrophotography, but photography.
Yeah.
Right. I think the daguerreotype came out in 1840s, Chuck.
Yeah.
Daguerreotype.
1840, okay.
So
Well, back then the film speed was like ASA 25 or less.
I think it was like ASA 0.1.
Yeah.
Yeah, it's real. Took long exposures, even with bright sunlight.
With those daguerreotypes in the 1840s, it would take up to 10 minutes to take an exposure.
Yeah. Yeah.
So anyway, this shows the ramp that you stand on, the curved catwalk, and these are the beams that it can be pushed out, so it can go all the way over to here to see when the telescope's tipped that way.
Oh.
Here it's pulled back out of the way.
Oh, yeah, yeah.
Well, you look like you're
He
on the middle.
also wanted to do something that he was laughed at for, but he succeeded at it. Never mind all the false ghost images. They had it in glass, and it's hard to get away from those. But he wanted to know what the temperature of the moon was. And so he built this, which is about a 24-inch diameter mirror, and it's about f1. So it concentrates the light, and it has a thermometer at the focus. And he pointed at the moon, and then he pointed at dark sky, and he got a fairly accurate measure of the moon's radiant heating because of that.
Huh.
So this is called his moonscope. And there it is, looking down the barrel. You can see it's highly curved.
Yeah.
A thermometer back here on Earth can tell you the temperature on the moon?
Yeah, it's infrared light.
Oh,
And
really?
that's how they discovered infrared light. Was they put someone, I forget now who it is. We talked about it in an earlier.
Herschel.
Herschel, yeah, I think you're right. And he put a thermometer in each of the bands of the spectrum when he's had a big prism to spread the spectrum out on a table in a lab, a darkened room. And he put some of the thermometers aside and they still registered. So he explored that. And he found infrared light that way. He discovered it, that there was a color we couldn't see, but it registered very well on the thermometer.
Wow.
Well, now, what kind of thermometer, Jerry? Would it have to go very low, wouldn't it?
It's just a regular glass thermometer that the used to measure the temperature in a room.
Okay.
Or
Wow.
if your kid had a fever.
They were clever.
They were clever, they were observant, and they were intelligent. They realized when things didn't make sense or they couldn't figure it out, and they noodled it out.
Let me just ask just an aside question here. If they had to do this whole thing over again, would we still come to the same place here scientifically?
If they did it the same way, we'd be here again.
We'd be here again. Okay, I just curious.
But remember, the most impressive thing to my mind is that in 1666, Isaac Newton hid out in his estate outside of London because there was a plague going on in London. And so he had all that time. He wrote the Principia, and in it, he developed his calculus and his 3 laws of motion. And what he wrote down then is what we use to send spacecraft so accurately to Mars and other places in the solar system.
Yeah, actually, he didn't write the Principia then. He noodled this stuff out, but he just sort of ignored it. He thought, okay, that's interesting.
Yeah, he got
later
chided into publishing it.
Yeah, he had a discussion with Hooke and with Herschel, or I guess it was not Herschel, Halley. It was Halley and Hooke. And they had discussions with him about, well, what do you think the force of gravity is? And Hooke says, well, I think it's 1 over r squared, but I can't figure out how. And Newton said, oh, I figured all that out years ago.
Yeah.
And it took them a long time to actually convince him to publish all that.
Right. That's Ron. That's where the phrase "by hook or by crook" came from.
He had an apple orchard, didn't he? Sit under those trees?
No, that's a myth.
That's
Oh,
myth.
is it really?
No, there
So
actually is an apple tree though that was on his estate that they've
Yeah, attributed that too, but
and they've also kept it alive too. They've cloned it or not cloned it, but scioned it. You know,
Mhm.
I forget the horticultural term.
Propagated.
Propagated it, yeah.
Mhm.
No
Nurtured
kidding.
it.
So it's not a
But there
myth.
was also a fellow in Germany that developed calculus too.
Leibniz.
Leibniz.
Yeah, Leibniz, and the word got out that he was going to publish, and that spurred Newton to publish too.
Right.
And
Yeah.
they
I
were-
read, Jerry, that the news traveled by, a cart, horse-drawn cart. And it was because of that, there was not much communication between the two fellows, until too late.
Yeah,
Yeah. I was gonna say, just one thing is that's an F1 scope. The only F1 scope I know about is up on Mount Graham, run by the Vatican, and it's a survey scope. They call it the Pope scope.
uh-huh.
Yeah. And Mount Graham is near Safford, Arizona, not too far from
They
Tucson.
sell ice cream up there too, Tom.
Yeah,
Is
right.
this-
The Pope.
Well,
Is
no,
the mirror-
Tim.
Yeah.
What do you do with holy water?
You burn the hell out of it, right?
Yeah, you put
That's
it in a
one thing
pan
you
and boil
do.
the hell out of
That's
it.
how you make it. But
You put it
you know,
in a
you can
pan
make-
and you
if you
boil the hell
freeze
out
it,
of it.
how about if you freeze it? What do you get?
I don't know.
Popsicles.
Pope tickles, yeah.
Okay, where did I lose control of this meeting?
Right at the
Is the
beginning.
mirror in this scope speculum?
Ooh,
Is the
This
mirror
is-
in that scope
This is one of
speculum?
the instruments in the museum.
Wow.
I can't decide if this was intended to go on the telescope. It's got all the makings of a filler micrometer to measure angles and spacings between stars, but it also
God.
looks like a microscope. But of course, that's what a telescope eyepiece is a
Mhm.
microscope. You make an image with the main mirror, and then you examine the image with an eyepiece.
Yeah.
But there's a lot of instruments in here.
Yeah. Precision engineering, huh, Jerry?
It's just beautiful.
Yeah.
Good grief! How did they cast those gears?
What do you mean? They just throw all the ingredients in a pot and they heat it up till it's liquid and then they pour it in the
Yeah.
mold.
Looks
Yeah.
like
And a sand mold would do that kind of.
No, they would
Oh, then
engrave
it goes
those.
to a lathe and a scribing or an engine to make the gear teeth.
yeah.
Oh, okay.
Looks like brass, huh?
Yeah. Man, that is beautiful.
Mhm.
so that's not a telescope we're looking at.
And we'll conclude today's meeting with a view
Kidney
of
stones,
a kidney stone.
Oh
kidney
my
stones in space.
A Scientific American has a little blurb they published, and I captured it, that
Yes.
studying, there's a continuing effort to figure out how space travel affects the human body. What adverse ways is there? And apparently it, from empirical evidence, it increases the likelihood of kidney stones, painful
Wow.
kidney stones, in people that have been in space for more than a month. And so they're trying to look at why, and they had quite a detailed thing about how zero gravity affects the human body and accumulates material that leads to kidney stones. There's a number of things that indicate that we're going to have to somehow develop effective Earth-like gravity for travel through space to get our astronauts there and back, and also shield them from radiation.
Mm.
Well, you
Wow.
can see why kidney stones hurt.
Yeah.
Thought that was a Van Gogh painting.
Yeah, it's just beautiful art.
So what are they going to do about it? Any clues?
Don't know that. They're still figuring out what it causes.
I understand they're going to.
The lack of gravity doesn't pull the stones down toward the outlet of the kidney. They
Well,
just float around in there.
apparently, zero gravity causes the tubes and passageways in your body to narrow and constrict.
Mm.
And so it lets these deposits build up that form the stones. And
And you
the
don't pass
chemistry
them,
shifts
huh?
also. They also know that astronauts lose heart mass when they're in space. And when they come back, they recover most of it, but not all of it. About 4 or 5% is never completely recovered, no matter how hard they work at it.
It also affects their vision.
Yeah.
Okay. So they're not going to spin the craft to give them artificial gravity, are they?
They might.
They might. I think they're probably going to do some version of that. Yes.
Gonna have to.
All their drinking water will be contained in the walls to keep away the radiation.
That could be done.
Drinking
All right,
water,
And they make hot
wastewater.
water.
When they
Well,
put up, I guess someone's planning to put up next year or the year after it, put up a small space hotel. And that will be rotated to give artificial gravity in the rooms. And the rooms will be formed out of bags that blow up that are inflated.
Bigelow, I think.
Yeah, something like that. You won't find me in one of those.
we're going to get that double ring rotating space station you see in 2001 Space Odyssey, huh?
Could be.
Not
That would
completed.
work, but that takes a long time to build.
I understand scientifically it was going too fast in the movie. You'd have weighed 1,000 pounds and crushed against the edge. Hey, gentlemen, we did it. Somehow got through the whole program. Let's do it again.
Jerry,
Right.
is there anything special I have to do to end this or just leave?
What's that?
Is there?
I'll take care of it.
Oh, okay.
Yeah, he'll kick you out, Tim.
Yeah.
Oh, okay.
Well, we got in our hour, and that was number 186. 187 is next week's. Happy Equinox, everybody. Don't forget the Zoom Online Telescope Workshop tomorrow night. The Super Harvest Full Moon is what, tonight or tomorrow?
Chuck, are we doing anything?
No, it's
No.
later this week. It's the
later-
night of the
later.
eclipse.
Okay, but it's not on the solstice day, not solstice. Equinox is Sunday, isn't it?
Yeah.
At 5 o'clock at night or something.
Yeah.
Well, sorry, our Saturday night star party was canceled due to cloud out, as Captain Outreach told us. And so till next time, as Chuck would say, hasta nebula, everybody.
Friday is Westmont. Friday is